Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to evaluate another limit. So we're asked to evaluate the limit as x goes to 1. We got cosine of pi times x plus 1 all over the square root of x minus 1. First thing I'm going to do is simplify this a little bit. So recall that cosine of pi is negative 1, so I'm going to write this as the limit as x goes to 1. And I'm going to write this as, now if I multiply negative 1 times x, I'll get negative x. So this would be negative x plus 1 all over the square root of x minus 1. That's the first thing you do first, is kind of simplify it if it needs to be simplified a little bit. Now what you do for any limit is you just plug in the value, because sometimes you might get lucky. You might end up just plugging the value in, you get out a finite value, and you're pretty much done. Notice that if we sub in positive 1 here for x, we'll essentially get 0 over 0, because negative 1 plus 1 is 0. Well, nobody really cares if it's 0 in the numerator. It's 0 in the denominator that's the problem. So recall that the square root of 1 is also 1. So we would essentially be subtracting 1 away, which would give us a 0 in the denominator. So we end up with one of those indeterminate forms again. And I always have to mention this, and it's very important to mention in these videos. An indeterminate form, which we get in this case is 0 over 0, does not mean that the limit does not exist. A lot of Calc 1 students assume that if I get 0 over 0 or infinity over infinity, there's actually 7 types of indeterminate forms. There's a few others, but these tend to be some of the more common ones that students run into, and they just assume, okay, well, there's nothing that can be done. In most cases, when you get an indeterminate form, there is something that can be done. You just have to apply some other, technique to evaluating the limit. So whether that be rationalization, maybe factoring, canceling some things out. If it's a trig limit, sometimes you can use trig identities. There's a variety of other things that you can do, and of course, L'Hopital's rule is in play, given that the conditions are met to actually use it. So it doesn't mean that the limit does not exist. I'm not saying that there aren't going to be some limits where the limit just does not exist. I mean, that is certainly can be the case in some cases, but it's important not to, think that because you get an indeterminate form that there's nothing you can do for the limit, because it's not true all the time. So in this case, since we know a direct substitution is not going to work, we have to come up with something else. Now, we talked about in plenty of other videos. One thing that works well when you have square roots, particularly, not all the time, but in some cases, is you can do some level of rationalization. And that's exactly what we're going to do in this case. We're going to rationalize this denominator here. And when I say rationalize it, I'm going to multiply this denominator here and the numerator by the conjugate of the denominator. And we'll see what we get. So in this case, we get the limit as x goes to positive 1. And we got negative x plus 1. I'm actually going to put it in parentheses. Multiplied by the conjugate of that denominator there, which would be the square root of x plus 1. And then we have to multiply obviously the square root of x minus 1 by its conjugate, which is the square root of x plus 1. And we see what we get when we simplify that. So we get the limit as x goes to positive 1. And if we simplify that, well, it looks like we'll end up getting negative square root of x minus 1. And then you try to plug in the limit again, or plug in that value of x again, and see what happens. So if we plug in the 1 again for x, well, it looks like we'll get negative 1, because remember that the square root of 1 is 1, but there's a negative there. So we'll have negative 1 minus 1. Negative 1 minus 1 is negative 2, which is actually the limit. So your final answer for this, our limit here for this problem, is just going to end up being negative 2. So this is just another good example of where we get one of those indeterminate forms and we were still able to find the limit using alternate techniques. And so that's going to be your answer for this. So let me know if you have any questions. I'll be more than happy to talk about it, and I'll see you guys next time.